Alright, welcome back to another video on my channel, math_exe. And today, before we are going to look at more examples of like average speed type questions, I'm going to talk about conversion of speed units. This is very important because in some questions, you might be given like speeds in a unit, but it will ask to express your answer in terms of another unit. So that's why I'm telling you this today. So let's say we're going to convert 36 kilometers per hour into meters per second. So just write this as question marks. Now what will you first do is to express this as a fraction. So 36 kilometers, and this is all over 1 hour. So this is just the distance traveled in 1 hour. So that means 36 kilometers is traveled in 1 hour, or you can express this in a rate form. And what would you do is you look at each units of the distance, and then you may ask yourself, well, how many meters is 36 kilometers? Well, you can just multiply that by 1,000 because 1 kilometer is 1,000 meters. So you get 36,000 meters on the top. And then look at the units for the time, and then you may ask yourself, well, how many seconds is 1 hour? Well, we know that 1 hour is 60 minutes, and 1 minute is 60 seconds. So that means 1 hour is just 60 times 60, which is just 360 seconds. And I'm going to write this right here real quick. So notice there's some cancellations happen very nicely. So notice these two zeros cancel with these two zeros. This 36 will cancel with this 36, leaving us with 10 on the top. I'll just erase this, and then we're left with 36 kilometers per hour is 10 meters per second. And what if we wanted to do the other way instead? So we're going to convert let's say 20 meters per second into kilometers per hour. And note, I'm only doing this with two types of units. However, the concept for converting into other units is basically just the same. So again, we'll just express this in a fraction form. So 20 meters over 1 second. And then first look at the units for the distance. Well, you may ask yourself, how many kilometers is 20 meters? Well, you can just divide 20 by 1,000, because 1 meter is actually 1 over 1,000 kilometers. So we can just write the units right here. And then this is all over. I'll just scroll down the border a bit. And then you may ask yourself, look at the seconds and look at the hours. Ask yourself, how many hours is 1 second? Well, that's just 1 over 360. Since we know 1 hour is 360 seconds, then 1 second is just the reciprocal of that. There we go. And maybe when you're not comfortable with this kind of fraction madness, so we can just write this as a division of fractions. So we can just write this 20 over this kilometers divided by 1 over 360 hours. And personally for me, I would like to write the units on the front just to avoid any confusion. So, well, first we can just cancel things up from this fraction. Notice that this 0 cancels with this 0. These two cancel this with this 100, leaving us with 50 on the bottom and 1 on the top. And then we're left with 1 over 50. When we're dealing with division, that means we can just switch the numerator and the denominator. And then change this into a multiplication. So 360 over 1, which is just 360. And then we can just cancel this 0 with this 0. And then we're left with 360 over 5. And if you calculate that, you will get 72 kilometers per hour. So notice that 720 kilometers per hour is equal to 20 meters per second. And that's all I have to say for this. I would say the strategy is to look for the distance units, and then you can just convert them and then do the same thing on the time units. Alright, let's get into some questions. Alright, for the first question, it reads as follows. So it says a car travels from point A to point B at an average speed of 45 kilometers per hour. After reaching point B, it immediately turned back to travel to point A at an average speed of 90 kilometers per hour. And then we need to find the average speed of the whole journey in meters per second. So that means we need to convert it in the simplest fraction. So we know that the conversion will deal with simplification of fractions. So let's just do a diagram to see what's going on in this question. So just draw 2 in this case for both journeys. So we have point A and point B. It says for the first journey it travels 45 kilometers per hour. And for the second journey, it travels from B to A at 90 kilometers per hour. However, we do not know anything about the distance or the time taken for each section of the journey. So what we'll do, well, we can just create a number or a variable. Let's just call it x. So x will be the distance between point A and point B. Well, with this information, we can just calculate the total distance and the total time for this journey. So the total distance, notice that the car traveled twice because it travels from A to B. That means it travels x kilometers, and I should have put x in kilometers. And then it travels from B back to A. So it travels twice the distance between A and B, which means the total distance for this is 2x. And remember, x is in kilometers. So for the total time, it might be not very obvious, but if you notice, for the first journey, the time taken will be just the distance over the speed. So there you go. So in this case, our distance is x for the first journey I'm talking about. So the distance will be x and over the speed, which is 45 kilometers per hour. And make sure when you write some information, make sure you also write down the units, because sometimes it could be confusing for others to read your answer if you didn't put any units. So anyways, since it's total time, we must add the time with the second journey, which is the total distance over the speed of the second journey. So we'll have x kilometers, that's the distance traveled for the second journey, and then in this case our speed will be 90 kilometers per hour. So notice this kilometer with this kilometer will cancel, as well as this right here. And then the hour goes on the top later. But I'll just extract the hour in the front later, so don't worry about that. So we have x over 45 plus x over 90 hours. We can just combine these fractions by multiplying by 2 on both sides, on both the numerator and the denominator of this fraction. So we can make the denominators the same. So we have 90, we just combine those two. So we have 2x plus x. And don't forget the hours. So notice this will become 3x over, and this will become over 90. And notice that this 3 and this 90 will cancel, leaving us with a 30 on the bottom, leaving us with this will be x over 30 hours. Alright, and now we're ready for us to calculate the average speed. So remember, our average speed formula is just the total distance over total time. So our total distance before we calculated that it is 2x. Our total time right here is x over 30 hours, and this is in kilometers. We're probably not very comfortable to deal with these fractions, so we just write this as a division problem. So 2x, and I'll just extract the units for our speed, and remember our units for our speed right now is kilometers per hour. So I'll just write everything right here. And then since we're dealing with division, we can just switch the numerator and the denominator, and then changing this with a multiplication, well, times. But I think I won't write this as the times. I'll just write this with a dot, because we have x with here, and I would be afraid if you are a bit confused. So anyways, the numerator will switch with the denominator, and this is, remember, this is kilometers per hour. Notice that this x and this x will cancel, leaving us with 2 times 30, which is just 60 kilometers per hour. However, we're not very done yet, because the question is asking us to find the average speed of the whole journey in meters per second. So we need to convert 60 kilometers per hour into meters per second. However, we can just write this as a fraction form, and then since we want this in meters per second, I'll just write this on top. So first look at the distance units and ask yourself, well, how many meters is 60 kilometers, which is just 60,000 kilometers. 60,000 meters, and notice that I just multiplied it by 1,000. And then do the same thing for the time units, and then ask yourself how many seconds is 1 hour, and just as I said in the last example, it is 360 seconds. 3,600 seconds, sorry. So there are some cancellations going on. So these two zeros will cancel with these two zeros. This 36 may cancel with this 6, leaving us with a 6 on here and 1 on here. So we're left with 100 over 6 meters per second. And you can just cancel this with the 6 to get 3 and 50 on the above. which leaves us with 50 over 3 meters per second. Or if you are not comfortable with this answer, you can just switch this into a mixed fraction. So this will be 16 2 over 3 meters per second. Or if you want to turn this into a decimal, it will be a recurring decimal. So it will be 16.666666 and so on. So it's usually denoted as a dot right here. So any of these three options will be correct. Alright, that's all I need to say for this question. Let's jump into the next one. Alright, for the second question, I would think it's pretty interesting. So it says an object travels a distance d, d is in meters, in t seconds at an average speed of s meters per second. If s is increased by 7%, find the percentage decrease in t if the object travels the same distance. And you must give your answer correct to 2 decimal places. So we may predict that the percentage decrease might involve like crazy decimal numbers and stuff like that. So first I would just try to express each variable in terms of the other variables. So we know the average speed, or s in this case, will be equal to the distance, which is d, over the time, which is t. And you can just express this in various ways. So this is the first one. You can also express d as s multiplied by t. Or you can also express t as d over s. And usually when there is like in a question involving like certain variables and you might be unsure which expression you want to pick for some substitution, I would say just try to express every single variable in terms of the other variables if possible. Okay, so let's just call our d1, d1 being our d1 case. For the normal case would just be s1 multiplied by t1. So notice I just used this formula right here. And let's just write d2 as s2 times t2. However, s2 is increased by 7% of s1. So you can just imagine it as s1, and you would add it by 7% of s1. And then you can just express this as a percentage of this. So we can just imagine s1 as 100% times s1. Notice that 100% is this one, so I did not change any values of this equation. So noticing that we can just factor an s1 out of here to get something like this, 107% multiplied by s1. Or you can just change this as 107 over 100 multiplied by s1. And so we can just write this as follows right here. We can just write this s2 multiplied by t2 as 107 over 100 multiplied by s1 and then multiplied by t2. Alright, and since we're given also that the object travels the same distance, that means we can just set d1 equals d2. And then we can just make a system of equations right here. So s1 t1 equals 107 over 100 of s1 multiplied by t2. Notice we can just cancel the s1 and s1 right here, leaving us with t1 is just equal to 107 over 100 multiplied by 102. And we might want to express this express t2 in terms of t1. And first we must isolate this t2, so we must get rid of this fraction out of the way. Now you may just multiply by 100 on both sides first to see what we will get. So in the left hand side we will have 100 t1 is equal to 107 t2. And then you can just divide both sides by 107. And you will get that this will become 100 over 107. T1, this is equal to T2. And now you may want to express this in a decimal form, but like I said, you don't really need to give a exact value because this is a non-terminating fraction. So we can just write this as T2 after plugging in this in a calculator. You will get this. This is approximately equal to 0.9346 of T1, like so. And then we know our T2, and then we also know our T1 for our initial value. We can just use the percentage decrease formula. So the formula is as follows. So if you have a percentage decrease, you can have your initial value, I'll just denote this as I, minus the new value, and this is all over the initial value. And since this is percentage, we may just multiply this by 100%. So notice our initial value is just T1, and this is because T1 is just the starting value of this calculation, and then our new value is T2, which is just expressed as T1 as so. So we have this decimal right here. So 0.39346 T1, and our initial value again is just T1, and this is multiplied by 100%. And we can just calculate the numerator, and this will become so let's see. So we'll have T1 minus this, so we can just write this as a subtraction problem, like so. T1 right there. Okay, so knowing that T1 will go down right here, and 0 with minus 6 is 4, and we borrow 1 from here, we get 5, borrow 1 right here, we get this is 6, and this is 0.0. So the upper one will be 0.0654 T1 over T1. This is multiplied by 100%. And notice that T1 and T1 here will cancel, and notice if we're multiplying by a multiple of 10, therefore we just count the number of zeros and then we just move the dot to whatever the number of zeros there are. So in this case we'll move the dot 2 places to the right, because we have 2 zeros in 100. So, and this will become our final percentage decrease of 6.54%. And we're also given to give your answer correct to those 2 decimal places, which is exactly what we did here. Okay, we might going to do one more example of this. Alright, for the last question, it says a truck can travel 36 kilometers in X hours. And for the A part, find the average speed in terms of X of the truck in meters per second, sorry. So we can just do your usual conversion business. So first we're just going to write this as a fraction form with x in the bottom right here. So this is the average speed in kilometers per hour. And then we're going to convert this into meters per second. So first you're going to look at the distance units first and ask yourself, how many meters is 36 kilometers? So you can just say that this is just 36,000 meters because I just multiplied that by 1,000. You can just do the same with x hours right here and ask yourself, how many seconds is x hours? You can just multiply that by 3,600, so you get 3,600 x seconds. The units now turn into seconds. So after calculating this, you will get that this will be equal to 10 over x meters per second, and this is the answer for A part. For B part, it's a bit tricky. However, if you can set up the equation properly, you might get it. So yeah. So it says the truck can travel 72 kilometers in 2 hours. So its average speed for this distance will be just 72 kilometers over 2 hours, which is just 36 kilometers per hour. And it says if its speed is increased by 18 kilometers per hour, so we can just set up an equation right here. So 36 kilometers per hour is equal to, so let's see, we have 18 kilometers per hour plus our original speed, since its speed is increased by this original speed. However, this is not the right speed we're going to substitute in. We're going to write in our 36 kilometers over x hour, or just write it in rate form. Since we're dealing with kilometers per hour, it's always best to substitute in the kilometers per hour speed as well. So this will be our modified speed, which is 36 kilometers per hour. Notice we can just subtract both sides by 18 kilometers per hour to get that we have 36 over x kilometers per hour is equal to 36 minus 18, because we just subtracted them. We will get 18 kilometers per hour on the right hand side. And from this you may already guess the answer, that x is equal to 2. However, in case if you didn't, I'll just do this anyway. So 36, we'll just multiply by x on both sides, so we have 18x on here. And then after this you can just divide both sides by 18. So let's see what we got. So we have x is equal to 36 divided by 18, which is just 2. And that is our final answer for our B part. And that therefore finishes the video. So hopefully you guys enjoyed this video. Please subscribe for more, because I will upload more videos in the future. And I'll see you guys in the next video. Goodbye.